You say go.
Okay, let's go.
Hello, and welcome to Reducing Pollution from Industrial Wastewater. This is an official partner event of the EU Green Week. My name is Stuart Reigeluth, and I represent Revolve, a communication group fostering cultures of sustainability. Revolve is the communication lead for the Horizon 2020 project called Zero BRINE that is about advancing circular economy business models to facilitate the recovery of valuable resources from industrial wastewater. The circular economy in its different forms is now the name of the game. So today's topic is very timely and in line with the theme of this year's Green Week, which is all about zero pollution. Today, we will hear from European Commission representative, Dr. Panagiotis Balabanis, who is head of the water sector at the Directorate General for Research and Innovation, and who will give some insights into where Europe may be headed with this important topic. We will then hear from Dr. Dimitris Zevgenos, who wears many hats, including that of Innovation Manager for the Zero BRINE project. He's also Executive Coordinator of the Water Mining Project and Managing Director of SILO. Then we will hear from Dr. Selda Murad from the TÜBİTAK Marmara Research Institute in Turkey, who will take us on a digital tour of the Zorlu textile factory that is one of the 4 pilot projects where the Zero BRINE technologies are being tested. Following these presentations, we will have an exchange of comments and questions with media representatives. With us today, we have Philippa Jones, Editor-in-Chief of the Energy Monitor, Ahmed Kocak, Managing Editor of the Daily Sabah, and David Duncan, CEO of Uska News, the reputed global news outlet about water. Welcome to you all. We look forward to your hard questions. And for those attending remotely, you can add comments, questions in the chat or Q&A option in the sidebar, and we will do our best to get to them. Dr. Roelof Mol, coordinator of Zero BRINE project, is also present to answer any specifics about the Zero BRINE project. So without further ado, let us begin. I will pass the floor to Dr. Balabanis.
Yes, good morning, Stuart. Good morning to everybody. A real pleasure also to join this workshop and also have the opportunity to also share a bit, the policy background to share, the importance of this project in the context also of the political also priorities of the Commission, and also to specify also the role of research and innovations in this circular economy. I would like to share, a few slides. I hope that you can also see these slides. What is the problem that we are going to face? And I think this is a bit illustration in these slides. The problem is that in today's also world, this intensive use of water resources, which is mainly due also to this what we call the linear pattern of our economic activities, which everything is extracted, used, and discarded. So this intensive use put a lot of pressure on our planet, and also this creates a lot of problems, threaten also our prosperity, economic prosperity, growth, and jobs. And here I would like also to highlight, also to illustrate, some problems which also illustrate also this issue. As you can see, between 1970 and 2017, the annual global extraction of materials also was more than tripled. raising now, we have more than from 27 billion tons, we have now 92 billion tons of materials which are extracted. And what is important is that this extraction rate also continues also to grow. It's more grown at 3.2 per year. On the other hand, you see that more than 90% of the biodiversity loss and water stress come from resource extraction and processing. This also has been also highlighted in the global outlook resources. And then parallel to that is only a very few materials which are wasted in recycling. So this creates, you know, requires a new paradigm, and this is what also the circular economy, which has been also proposed, is trying also to reject this linear model of resource and trying also to adopt a more regenerative model where all the materials and the products also circulate in such a way that minimum of material is wasted and dissipated outside also our economy. What is also important to see is that the importance of green economy has been also highlighted in the recent, you know, European Green Deal. And I would like a bit, you know, to remind you that this, why, for instance, also the Commission also adopted this Green Deal. Because this is the realization that the this degradation, environmental degradation, reaches such a magnitude and dimension that also the fundamental physical and biological systems of our planet Earth are on the brink of collapse. And so, of course, the climate is the most discussed system in danger, but along also with the climate change, we see also ecosystem degradation, biodiversity decline, nutrients overloads, and soil, water pollution, and many other also kinds, all of them at global scale and at unprecedented also levels. So the Green Deal is a policy also response also to these also challenges. And what is important, as I said here, is green circular economy is a fundamental also component on that. This Green Deal, I don't want to go more on the details, but what it is important is this is a comprehensive also plan of more than 35 actions, which goes along the entire life of cycle of products and aims, for instance, between different things also to make sustainable products also more the norm at the EU, to empower consumer and public buyers. I think this is having also the consumer also the possibility, giving them the possibility also to select the most sustainable also products and materials. So this can give also more incentives, you know, for circular economy, but also to ensure less waste and make also circularity work for people, region, and cities. And last but not least, also lead global efforts also at the circular economy. What is also important to mention is that although the circular economy focuses in key product value chains, as it is also, you can also see here, is about, you know, packaging, is about plastic, is about textile, construction and building, you know, food, water, nutrients. What is important to mention here is that this sustainability challenge, which is posed by these key value chains, also requires a kind of a systemic also type of approach. And this is also is very important, is to the systemic holistic type of approach, that it is needed also beyond also the importance of the different sectors. And water also is an important also natural resource, which of course is wasted, but also the problem is that across also the globe, water also is becoming also increasingly also scarce. And this is also due to several also climate change, urbanization, and also the request, for more water for our projects, for our products. On the other hand, we can see that there is an untapped potential, for instance, for reusing also the clean water which is also can be recovered, from wastewater treatment plants, because as you see, only a very teeny proportion of the treated urban wastewater, for instance, is used for water supply. So applying also the circular economy principles in the water will also provide also several gains, and I think in particular this is also important if we are also focusing on water industry, and this is later on the BRINE Zero BRINE also project will also mention also who illustrate also these possibilities, because this will create also market opportunities for these industries, and we know the importance of these market opportunities for creating jobs, because it has been estimated for recent studies that 1% increase in the rate of the growth of water industry in Europe could create more than 20,000 new jobs in this sector. Let me finishing then my
Excuse
small.
me, Panagiotis, sorry to
Yes.
interrupt you. There seems to be a small glitch with the screen display where we're seeing a gray rectangle on the side, so we can't see the full presentation. Could you try closing it and opening it, please?
Okay, let me.
Sorry for this.
Stop sharing and try to share it again. Sorry for that.
Little technology glitches are part of the fun.
Is this better now? Can I put it also?
Still there.
I believe it is a security feature from Zoom.
Maybe you can minimize that if there is a minimization button there.
Is this better now or?
Let's carry on. Let's carry on. Sorry for interrupting.
Okay, well, is this okay? So this is in any case is the last also slides, but I would like just to strengthen that the importance of research and innovation on for the realization of the circular economy, because research and innovation is necessary also to demonstrate also that the circular economy has also potentials, for innovation across the sectors and the value chains. And I think a good illustration we'll have with the Zero BRINE project. But what is also important is that the research and innovation can also facilitate also the integration of the circular economy approaches together also with other challenges. So trying also to link also circular economy with climate change, sustainable water management, for instance, sustainable food, but also protection of ocean and seas also for pollution. But while what is important is to say that while also the previous also activities have been also focused more on specific and partial challenges, more on, for instance, on recycling technologies or product design for circularity, what is important is that future activities, as I said, they will have to focus more on the systemic, type of approach and solutions, which also trying also to close also the gap between, research and market uptake of circular solution, because as I said, this is also a very important element. And for that, I think the current Horizon Europe is the new framework program, which is, a very ambitious, framework program at global scale, is going to be used and is going to also to support also actions across different clusters and pillars of Horizon Europe. But not only Horizon Europe, but also other financial instruments like for instance, the circular bioeconomy investment funds, the InvestEU, the structural funds, but also the recovery resilient facility. These are also instruments that they are going also to finance also the market uptake of innovative solutions. And we, regards to the Horizon Europe, we expect now to have very soon, by the mid of June, to have also the formal adoption, and the first call for Horizon Europe will be also launched and available. With that, I would like to thank you and pass also the floor to Dimitris for the next presentation. Thank you.
Thank you very much,
And
Dr.
sorry for these
Balavanis.
problems with the display.
I'm trying to share my screen, and I will first minimize this gray thing. I guess you can see my screen in full presentation mode, right?
Looks good.
Excellent. So I'm going to speak about circular economy and industrial wastewater. As we had the introduction by Stuart, I am the innovation manager of Zero Brine project and the executive project coordinator of water mining projects. So I'm going to present that through those two projects. Now, speaking about circular economy, we have to see that through the eyes of the European Commission, and Dr. Balavanis has already done an introduction into that. The former European Vice President, Jyrki Katainen, had said that the circular economy needs more than traditional R&D or a piecemeal approach to technologies. It is, as we are speaking about a transition, it needs structural changes in entire systems and joint efforts by all actors, from technology centers to the civil society, etc., and of course, investments. Now, the European Commission, only within 2018-2020, they had invested €1 billion for circular economy projects. And if we put more light into that to see the water-related projects here, Mr. Milukas, head of Unit B3, Biodiversity, Circular Economy and Environment from REA, he has informed us that within 2014-2020, 84 water-related projects related also to circular economy have been granted from Horizon 2020, investing €500 million. Now, two of those projects I'm going to present to you, maybe the most promising ones. So Zero Brine and water mining. Now, Zero Brine project. It is about redesigning the value and supply chain of water and minerals. A circular economy approach for the recovery of resources from the salty wastewater, from the brines generated by process industries. The European Commission has invested €10 million into this project, into 21 partners. The project is being coordinated by TU Delft. Now, within this project, we have 4 large-scale demonstrations for water and circular economy. One in the Netherlands, one in Turkey, and we're going to hear about that from Zelta later on after my presentation, for textiles, one in Poland for coal mining, and one in Spain for the chemical sector. And let's dive into that. I had to select only one case so that you can see our results. Now, if we see the case of the precipitated silica sector, of course, the name that you can see here, IQE, is our case study, the factory in Zaragoza. They use, of course, raw materials. And you can see this quantified here. Let's not go into detail about that. Now, what they are doing is that they are producing precipitated silica. And this is a product that is being used in the plastics industry, but also for the tires industry. So the road transportation, the car that you are using, the tires are using precipitated silica. Now, if you see the whole market, you have 11 production sites in Europe producing 750,000 tons per year. 6 companies are producing that, Solvay, Evonik, etc. And the market size is around $500 million, just to understand a little bit of figures about this market. Those 11 sites, they are now producing wastewater, which is mostly with sodium and sulfates involved into that. And they are treating that maybe in neighboring wastewater treatment plants, and they are discharging into the rivers or into the sea. What we are doing instead in Zero Brine, we are taking the wastewater and we are recovering the resources. The technology that we are using is nanofiltration, evaporator, and eutectic freeze crystallization. And this is now being supplied into the Zero Brine task force. So all the technology suppliers have joined hands in order to make this into the market, because we heard from Dr. Balabanis that a lot of times you have the research, but it is not being implemented into the market, especially for circular economy. Now, through those technologies, what we have achieved is water recycling more than 70% internally within the factory, but also external valorization opportunities. So the sodium sulfate is now being recovered. And what is important here, and that is the complexity of circular economy, is that this is a totally separate value chain from the precipitated silica. So the precipitated silica producers have nothing to do with that. So you need to somehow connect those different value chains. The sodium sulfate, just to give you an idea, is being used in the detergent industry, totally different. Now, let's see how we can make it to the market. By the way, IQE is adopting this solution into full-scale implementation after the Zero Brine has been successfully implemented. Now, enabling or even building the circular transition in this precipitated silica sector. As we said, transitions require structural changes, and that has to do with the whole socio-technical system or regime. And for that, you need a window of opportunity. The political priorities that we heard from Dr. Balabanis are extremely important because they are creating this window of opportunity through a shock to the regime. So for us, the Industrial Emissions Directive and the BREF, the best available techniques for this specific sector, large volume inorganic chemicals, is now happening this year. So that creates a good opportunity for us. The Zero Pollution Action Plan that has been adopted, of course, the EU Green Deal that we heard from Dr. Balabanis, the Sustainable Chemical Strategy, all this. Apart from that, what is happening at a local level, because you need some local actors to be the front runners for that. In Zaragoza, there is a limitation to IQE to expand their business opportunity. Why? Because there is regulation that they're telling them, no, you cannot discharge any more wastewater into the river. So they need to adopt a zero liquid discharge, and they need to adopt a circular economy solution. The market demand, of course, that was very, very important because it was signaling that we need more precipitated silica because of the green tires market. Now, the processes, you need innovation for that. And this innovation comes through Zero Brine. The task force is really important here. Why? Because you have different technology suppliers that you need to align their interests. And after you have the whole treatment train, you create the momentum that you need to transform the regime. And then after you have transformed this regime, you need, of course, to influence the policy-making process on the bigger landscape environment, because then you create evidence, and then this can create the new policy and legislation that you need to adopt that into the regime. Now, all these I am presenting in the New Business Models Conference in June. So 10th of June and 11th of June, I'm presenting more information about these, the Zero Brine Task Force and the chemical sector. So you are more than welcome to join this conference. Now, if I may use a couple of minutes, water mining is a follow-up project that started last September. The title is Next Generation Water Smart Management Systems, large-scale demonstration, but this time for a circular economy and society. The societal aspect is really important here. It is a project of 19 million euro with 38 partners. It's a very big project and is being coordinated again by TU Delft. One slide about the concept. We are looking into the water throughout the value chain. And if you see that throughout the value chain, you have to see that water as a resource or water as a product. And if a product, it is a consumable product or a durable product. And we have established 3 lines of research and demonstrations for that. So we have the sea mining, the urban mining, and the industrial mining cases. Only the last one is relevant. So this is why I will just dive into that mostly. But namely for the sea mining, we have 2 cases, one in Italy, one in Spain. For urban mining, we have 4 case studies in the Netherlands, Portugal, Cyprus, and Spain. And now for the industrial mining, we have 2 case studies, one in the Netherlands and one in India. That is a chlorine sector in the Netherlands, and you will see that in the next slide, and a sugar factory in India. Now, let's have the final slide about this industrial mining case. You have the map of the Netherlands here with 4 areas of chlorine clusters. And the most important or the biggest one is in Rotterdam port, where we are having our demonstration. So if you see the chlorine cluster in Rotterdam, it is AkzoNobel, now it is Nouryon, that is applying this chlorine to 4 main clients, and we're establishing chlorine recycling from Hexion that you see here back to Nouryon. For this, circular economy business modeling is also really important. We are testing the chemical leasing concept, and if you have any questions about that, I will be more than happy to reply. Thank you very much for your attention. These are my contact details if you would like to communicate with me.
Thanks very much, Dimitris, for the details and the insights
very
into
welcome.
these ambitious projects. We're going to take a deep dive now into the Turkish pilot project of Zero Brine. And so I'll invite Ms. Selda to unmute herself and share her screen and take us on this digital journey to your country. We would have liked to have been there in person, but because of COVID, we're restricted to the digital world for the moment.
Right. Good morning, everybody. My name is Selda Avcıoğlu. I'm senior researcher in TÜBİTAK Marmara Research Center. And my main expertise is wastewater treatment technologies. Today, I will be presenting our pilot study on textile company. And is it okay? Can you see my screen? Did I manage it?
Yes, it looks good.
Okay. I will be presenting our pilot study for the textile industry, and I will talk on the environmental impacts of the textile industry and how we find solutions to mitigate the environmental problems caused by the sector. And I will show you our Zero Brine pilot plan and technology and process, and I will show the results. The textile industry in Turkey is a very important sector because it makes up 10% of Turkey's GDP, and Turkey ranks 5th and 6th worldwide in production of wool and cotton products, and the sector employs 750,000 people, which is quite high. And Zorlu, which is one of our pilot partnering project, is one of the largest integrated polyester yarn and cotton textile manufacturer in Europe. Let's see the overall distribution of the textile sector in Turkey. As you see, the sector is distributed all over the country, but the biggest ones, large-size companies, are mainly located in Marmara region and Aegean part of Turkey. And when we look into the environmental impacts of the sector, the industry is well known with its...
Selda, I'm sorry to interrupt you. Could you scroll down so we can join you on this?
I scroll down actually. Do you see the text?
It seems to be stuck on the opening, visit the Zorlu textile
Really?
factory in Turkey.
Okay, I will refresh the page.
There, now it's going.
Okay, I will just refresh. Is it okay now? Can you see?
Now it's moving, yes.
Okay. Sorry. The textile industry is known as its high water consumption. It's water intensive sector. The water consumption ranges depending on the product, and for example, for cotton productions, it's like 60 to 120 liters per kilogram of products, but for the wool product, it's much more higher, like 110 to 650 liters per kilogram wool. And the water is used for dyeing, rinsing, and finishing operations, and they all require extensive water use. And the other important material for the textile industry is salt. Salt usage is also significant in the industry because salt is used in dyeing of cotton and linen fabrics. Salt acts as a raw and auxiliary material, but also results in salt wastewater stream. So it also creates a highly polluted brine that can have serious environmental and ecological impacts, especially for the inland receiving water bodies such as lakes and rivers, and it may cause salinization of the soil, as you know, which is one of the most severe environmental problems in agriculture in lots of areas in worldwide, because the soil lost its fertilization capacity, and sometimes this is caused by natural phenomena. Sometimes it's because of the excess irrigation and inadequate drainage, but sometimes it's because of industrial discharges which has salt in their wastewater. So it's an important problem. So in the BRINE project, we are using new and existing technologies to help find circular solutions to these BRINE challenges. And this is here you see our pilot system installed in Zorlu Textile Company. You see this BRINE blue storage tanks. The wastewater generated, the brine generated in the company is pumped into this blue storage tanks, and in this container we have technologies to reuse to treat and reuse the brine. I will show you more in detail the technology we use. The project, the Zero Brine, is redesigning the value and supply chain of water and minerals by taking a circular economy approach to close the loop and improve the environmental impacts of production. And our work involves initial comprehensive physical and chemical characterization studies of this brine generated in textiles industry. And then we conducted lab-scale treatability studies with various technological options. We tested nanofiltration, oxidation, ion exchange to remove the impurities from the brine that can be, and to achieve to be reused in the dyeing process. And then we designed a pilot plant and installed it in the company. And now still it has been under operation for some months. And the company is located in Lüleburgaz in the Marmara region of Turkey. And all these studies for the textile industry is led by TÜBİTAK, which is the Scientific and Technological Research Council of Turkey. We are developing an innovative brine treatment system for the textile industry with the aim to recover concentrated salt solutions for reuse in textile dyeing process beds. The aim is recovery of resources from brine generated by industry, reuse the minerals and water from the brine inside the company, or it's also possible to reuse it in other industries. And the main aim is the reduction of discharge of saline wastewater streams mainly to the inland waters. So the company, let me to show you what was already available in the company to treat their wastewater and what we have done to recover the brine. So the company has a wastewater treatment system with physical, chemical, and biological methods, and also to reuse their wastewater, they installed an advanced treatment process which consists of activated carbon absorption, ultrafiltration, and reverse osmosis. Reverse osmosis is the process where the brine generates, and it's the generated brine was discharged back to the influence of the available treatment technology. I will show you a scheme to overview the whole process and for a better understanding. This is the textile industry where the wastewater generates. As I mentioned, it consumes lots of water for the production. So the high amount of wastewater is treated in chemical and biological treatment first, then partial, not the whole amount of the wastewater, but some of the wastewater is treated in an advanced treatment plant for the reuse purpose. And this is where the brine generates. The reverse osmosis concentrates contains high amount of salt in it, but also the impurities, because the recalcitrant or resistant organics to the degradation like dyes and colors and organics still remains in the brine together with the salt. So we developed the technology to remove these impurities, color, organics, which have recalcitrant characteristics, so it's difficult to remove them, and also the hardness and sulfate, so on, that can be to reach the quality that can be reused in the process. So after our process, the concentrate treatment and recovery system, the brine is a brine solution, the treated brine solution is reused for dyeing process in the industry. And also we produce reusable water for the process during this treatment system. The CD process that we use in our pilot system. As I mentioned in previous slides, the wastewater, this brine contains high amount of resistant organics. So we applied an oxidation process to remove the organics and color, which are important to be used in dyeing process. So by the ozonation process, you see the picture on the right-hand side, we removed 70% of chemical oxygen demand and over 95% of color. And following the ozone oxidation process, we applied nanofiltration process because still there are some residual organics and color in the wastewater and also hardness and sulfate. So we applied nanofiltration to remove those pollutants while keeping the salt in the permeate. So in this process, in addition to the ozone oxidation, we achieved an additional 30% of organics removal, 50% of color, 50% of sulfate, and 40% of total hardness. But in this process, we lost some of salts, which is 10 to 15 and also 16% of the total dissolved solids. And after the nanofiltration process, you see the picture on the right-hand side, we use ion exchange process. Hardness is one of the most important parameter for use of the brine in dyeing process because it affects the performance of the dyeing process and the quality of product. So hardness is an unwanted pollutant. So we remove the the residual hardness by cationic resin units. So to achieve the reusable quality. And finally, we applied reverse osmosis process for concentrating the brine. And with the reverse osmosis process, the feed's TDS concentration can be concentrated up to 4 times. You see the picture of reverse osmosis system in our pilot on the left-hand side. And this concentration is sufficient for the textile dyeing process. And in this reverse osmosis process, we also produce clean water that can be utilized for several purposes within Zorlu textile. And what is the benefits of this study for the textile industry? Let's have a look at it. Our pilot plant capacity is 300 liters per hour of reverse osmosis for reverse osmosis retentate. So this discharge is prevented for the industry as a result of our pilot study. And the process results in 50 to 60% of recovery of sodium chloride for dyeing process. And also it's possible to reuse, it may be possible to reuse some part of the sodium chloride for the softening process. And 70 to 8% of reusable pure water stream for process is achieved. And if the process is upscaled to the full wastewater, like real size scale, it's possible to recover 400 tons of brine concentrate per year. And based on the carbon dioxide equivalent of salt and water recovery, there's a potential reduction for the emissions of carbon dioxide. And overall, this is helping the textile industry in achieving resource efficiency and improving the sustainability because the company has concerns on environmental production and sustainable production, and it affects their visibility. So it's also good to show that they are promoting for improving their sustainability. So using existing technologies, the project is closing the loop on saline wastewater and contributing to the circular economy. It increases circularity with the reduction of saline wastewater streams by recovering and reusing minerals. It has potential to increase their visibility because lots of people has concerns on environmental issues. And in addition to that, there is a potential for creation of job alternatives for technical personnel. Although the sodium chloride is a cheap material, still there's an economic benefit that comes from a reduction in consumption of salt and water. But mainly we are helping business become compliant with relevant regulations, so that's important. As already mentioned by Dimitris, there are 4 pilot site partner countries in the project. You can see them as a pink in the map. One is for a demineralized water plant, a coal mine, and a silica factory with possibilities for wider application in the future. If you are interested in them, just you can click the links for getting more information. And the other issue is sometimes it's not always possible to reuse the generated brine on site in the producer company. So it's important to match the potential reusers. And in this project, an example of an innovative prototype platform, which is in the domain of saline wastewater management, aiming to promote resource efficiency and circular economy, an online brine platform is developed. And this works, this platform matches brine owners and brine users and also technology providers in this platform. So if you like to have more information about the platform, we have some videos. You can just click them and enjoy and see how it works. And thank you for your attention and listening. Thank you.
Thank you, Selda. Thank you very much. Teşekkür ederim.
You're welcome.
We have a few questions directed towards you in particular from YouTube and the attendees here. However, I'm going to put those on hold for one minute. We'd like to hear from our colleagues from the media, and we put our brave presenters on the stand, on the spot a little bit. Let's hear from Philippa Jones, and then Ahmed, and then David, in that order, please.
Thanks, Stuart. Hi, everybody. Thanks for the presentations. They're super interesting. It's really good to see all this work going on. I work on energy, so what I'd be really interested in is to know, in terms of climate action and the energy transition, whether these projects or other projects are going to be able to use certain of these minerals, especially in terms of batteries. I think the Commission mentioned the batteries obviously is a big area. And obviously in terms of talking about circular economy and sustainability, we probably shouldn't be importing everything we're going to use for the energy transition and climate action from outside the EU. So yeah, so a bit of clarity on what work and how this actually fits with the climate action and the energy transition agenda. Thank you. That's probably directed towards the Commission. Sorry, thank you.
Okay, thanks, Philippa. Let's take the comments and questions in turn, and then we'll ask the panelists to respond. Ahmed? You just need to unmute yourself.
Hello, Ahmet Koçak from Daily Sabah. I don't have any immediate questions, so you can move on. Maybe I'll come back later.
Okay, that's fine too. Over to you, David.
Hi, and thank you for having me, Stuart. David Duncan from USFA News. Our readers and viewers are particularly interested in water. That's what we write about, including the growing awareness in the corporate and manufacturing world of water responsibility and indeed water risk. And these are fascinating technologies. Maybe this question is a little bit early in the game for the Zero Brine project, but has there yet been engagement at Zero Brine level or at pilot level with the entities that provide auditing and certification processes for water responsibility? And there, I think of Alliance for Water Stewardship and WWF and World Resources Institute, Carbon Disclosure Project, the tens of thousands of manufacturing companies and their portfolios who have achieved water responsibility certifications. has Zero Brine at some level started to engage with these processes?
Great, thanks very much, David. So over to you, Dr. Belabanis, for the first question, and then Dimitris, if you want to try to tackle the second one.
Yes, thank you very much. I hope that you can hear me. As I said, the opportunities, the link between these activities, circular economy, and also energy efficiency, I think, are very, very important. And although in Zero Brine, there have been also several perhaps activities, and colleagues can probably give more details. I think I would like also to stress that I think these links between circular economy, water, and energy also are also very important, and they also have attracted a lot of interest. I would like to just perhaps to mention about also a project which has been supported. It was in the context Dimitris also mentioned, more than 84 projects which are running. And I think this is a project which also finished. It is a project which is called Powerstep. And this project also tried to demonstrate that, because nowadays, everybody speaks about, climate also neutrality, and trying also to ensure, that also the treatment, it generates the same amount of energy as it is consumed, in particular also in the municipal wastewater treatments. So this project also trying also to and demonstrated that we can also go even beyond. That is not only that we can also achieve also this neutrality, but also a wastewater treatment plant also can also be produce also electricity, and this is something which is very important. This is the this Powerstep, and I will be happy also to share also some links also to this project that also demonstrated that we can also have very benefits, and also to demonstrate also this. So this is certainly, as I said, the links. We know that energy requires water, and water also requires the energy. So this energy nexus, I think, is an important element that has been also clearly also looked at. Thank you.
Okay. Dimitris, would you like to try to address that question of the auditing?
Well, thank you very much, Stuart. It is about the water responsibility certifications.
Mm-hmm.
That is a very interesting question. I think more contribution could come actually from Revolve, that has been very active in that field within Zero Brine. What maybe I could add to the discussion is to provide more evidence about the energy transition, like Mr. Balabanis said, because in Zero Brine we do have a lot of activities in that and in water mining. So I think it is very, very important, the designers, to have all these climate neutrality objective in their objectives of the design. And this is what we do in Zero Brine. So in one of the case studies in Rotterdam Port, this is an industrial cluster. So you can have a lot of waste heat there that you can recover. From studies that we have done, you can have around $6 billion per year of waste heat, let's say, that as a value that you can use to really drive the processes. And this is why we design our systems in that respect, to recover the waste heat that you might have either through low pressure steam or through condensate streams in industrial clusters. Now in water mining, we are doing the same for desalination and brine management. In Italy, we are recovering from Lampedusa Island below Sicily. We are using the waste heat from a power factory to drive the processes, but also in Almeria, the second case that we have in Spain, we are using renewable energy, solar energy. So that is super important, and we are providing evidence through both projects for the energy transition and how you can couple that with the water treatment circular economy solution.
Okay, thanks, Dimitris. Philippa and David, did you have a follow-up as well or not?
Sorry, no, I'm good. Thanks, Stuart. I think it'd be
Okay.
nice though if you could share the links from the commission. That would be really good on the other projects that were sort of did the link between wastewater and or water energy nexus. That would be really interesting to follow up on. Thank you.
Okay. Yeah, we took note of the Powerstep project, and we'll try to add it in the chat as we go here. There it is. It just popped up. Okay, Selda, there are a couple of specific questions to you that I want to get across as we're on this call now. One is, what's the environmental pollution taxation system like in Turkey? Does it exist or not? And the other question was, what technologies are used in the concentrate treatment recovery system? Over to you.
Okay, thank you, Stuart. Regarding the technology we use for the treatment and concentrate the brine, we first, as I showed in the digital journey, we first remove the impurities using some pre-treatment systems, which consist of oxidation, ozone oxidation, and nanofiltration process. We try the absorption and other processes and measure the performance to achieve the highest recovery during our bench scale test. So the most efficient was the ozone oxidation and nanofiltration. So to remove the impurities, we use those technologies of ozone oxidation and nanofiltration. For the concentration to increase the concentration of the brine, we use reverse osmosis because we had chance to reuse the concentrate within the company. There are some more factories in the same region belongs to the same company, so that there's a potential to be reused in the same place. So we didn't increase the salt concentration more. We didn't apply crystallization. We didn't need it. So for the concentration of the brine, we use reverse osmosis, and up to 4 times we could concentrate the concentration. And for the first question, there are some discharge limits in Turkey for the industries. Each industry has different discharge standards depending on where they are discharged and what pollutants they have in their wastewater. And they should have complied those regulations. And if they don't, they have to pay some like punishment cost. And if they are discharging to the sewer, and if they have higher concentration than required discharge standards, they pay some like kind of tax. It's calculated by the flow and how higher your concentration is. And I think I saw one more question. Moving off the brine, if it is costly. Yes, if there isn't a potential user nearby, then it could be costly. You have to remove the water and you need to dry the salt, like crystallization, so on.
Mm-hmm. Okay, great. David, I sort of skipped over you. Did you have a follow-up on the water and policy side of things?
No, I didn't, Stuart, but Uskanius is going to be doing a series on industrial wastewater of feature articles, and one of our reporters is watching on the site through YouTube at the moment. So we may be, I think we'll be in contact with you and with some follow-up questions or introductions directly to the participants, and just thank you for a very interesting day.
Excellent, excellent. We're going to come out with a special report later this year with Elsevier on industrial wastewater as well. So we'll be sure to keep you guys in the loop. Dr. Balabanis, as we mentioned bilaterally, it'd be great if you gave us some closing insights into the growing importance of water in the broader policymaking side of things in reference to it not being present in the Paris Agreement, for example, as you said. If you want to give us some closing remarks on the importance of water, that would be great.
Thank you very much, Stuart. Also a pleasure to also, I think, to also address some the wider policy context, as you said. And yes, we discussed about the climate change, now biodiversity. These are the political also priorities. And I would like also to come back to this also water in the context of the discussion. Water is the the invisible actor in these discussions, and as we said, of course, many people, and water was not really perceived as a fundamental component in the climate discussion. It was reported, if you look, for instance, in the Paris already agreement, the text in 2015, there is rarely any reference, to water on the text of the agreement. But on the other hand, I think in the last years it became more and more evident, that water is also is a key component, and water is an important also component for achieving also climate adaptation, and also climate mitigation. Climate mitigation is, in wastewater treatment plan, by better reducing also the greenhouse emissions. I think we can also contribute also to reduce also the greenhouse emissions. But on the other hand, I think the climate adaptation, how to cope with, the extreme events, scarcity, flooding, how to better also govern water. And I think this is important, is that, water governance traditionally didn't also consider, circular economy principles. I think this is very important, and this is going also to be looked. We would like also to see also in the context of the climate adaptation, also to see the potential, for instance, of water use. Nowadays, for instance, still member states trying also to focus more, invest more on, for instance, on pipes, on engineering solutions, creating dams for, foster also the supply. But on the other hand, there are a lot of potential, for instance, in the water using, and this is also can be also applied, it can be also demonstrated, and we have also several projects that they are going to look on that. I would like to mention in particular in the context also of missions, within Horizon Europe, also the Commission sort of proposed the missions as a new way to implement, to achieve, the impacts, to try to achieve impacts on research activities, and also trying also to attract also the interest of the citizens, that people also understand exactly what research is doing and how research can also be relevant to their challenges and their problem. And I think in the context, Commission proposes, 5 missions. One is a mission on cancer, and the 4 other mission, which is about climate adaptation, is about healthy oceans and inland water, is about, healthy soils, and about also sustainable cities. I think all these 4 missions there have strong water resources elements, and I think in particular the climate adaptation, rethinking, the water that we use, we manage also water, I think will be one of the key areas where we would like also to give some more emphasis.
Great, thank you very much. And water as the relative newcomer, let's say, to the climate debate will be a hot topic to watch over the next months and years. Dimitris and then Selda, if you guys want to have a closing remark, go for it. Try to make the link to energy and a visit to Turkey.
Yeah, a very short a closing remark from myself is that, as I told in my presentation, circular economy and this energy is a transition. So you need to move from one socio-technical system to another socio-technical system. And for this, you need, of course, innovation, but not only technological one, but a systemic innovation. So that is that needs to be very well understood. We are doing some research in that. As I told you, I invite you to join also the New Business Models Conference, where I'm going to discuss about that more in detail. And then that I would like to close my remarks, Stuart, with this.
Thank you very much.
Thank you.
Zelda, and then we'll go to Roelof.
Thank you, Stuart. I think our technology developed in Zero Brine project is quite important to recover the salt. But in addition to that, for textile case, it's important to use the waste heat to reduce the energy consumption. But in our case, it was not possible due to the location of the company, the factory, and the generated brine. But for further studies, I think it's an important step to reduce the energy consumption. I think it's all from me. Yeah.
Great, thank you very much. Lastly, I would like to give the floor to the coordinator of Zero Brine, Dr. Roelof Moorn, who will say a few words about the final forum that's coming up around the corner and that we invite you all to participate in. Roelof?
All right, thanks, Stuart. It's a pleasure to announce to all of you the final conference, the final forum of Zero Brine after 4.5 years of intensive cooperation on circular economy and reducing pollution from industrial wastewater. We are ready to present our results, both on the technological side as well as on the business modeling side, the policy side, and it proves to be quite a interesting day. It will be the 4th of November. It will be in Delft, and we aim to have it a live event in the traditional sense, post-COVID event. And so I'd like to invite you all for that. Second, I'd like to thank all participants today on taking the time and opportunity to get aware of the developments that is now the innovative developments within Zero Brine. I'd like to thank our panelists, Dr. Balambanes from the Commission, and Dr. Xevginas, our innovation manager, and Dr. Zelda Murat about the virtual tour through the Zorlu textile pilot. I'd like to thank our panelists, journalists, Philippa Jones, Ahmed Kozak, and David Duncan for their questions and inputs. And also, of course, I'd like to thank Dr. Blanca Saez-Lacav, our project officer from IASME, who was also able to join us today. And finally, Stuart and his co-workers for setting up and moderating this event today. I thank you all, and hope to see you all back in early November, 4th November in Delft.
Thank you, Roelof. Thanks everybody from our side. Have a good day. We'll follow up shortly.
Thank you. Bye.
Thank you.
Thank you. Great.
Yeah. Thank you.